So continuing our journey, today we would be starting with CSS and we would try to understand little bit of code, and then we'll see a little bit of theory, and then we'll try to understand different CSS property and how it works. So CSS basically stands for cascading style sheets. Okay. This means cascading style sheets. So basically we'll see what is the cascading effect, and it is a style sheet. It is called as a style sheet because it gives or indicate the different styles that element has. So hence it is called as a style sheet. Now cascading, we'll see the cascading effect later on when we when we go in. We'll see like what is this cascading effect and how does that work. Now let's see how first the rendering is going to happen in a browser. So the first thing that is basically is the HTML that is going to, the DOM tree is basically going to be generated from the HTML tree. Oh, sorry, from the HTML. Now basically the DOM tree defines the structure of how the web page is going to look. Now after the DOM has been generated, then the CS object model or the CSSOM tree is generated. The CSS parsing will happen in the following method. First is basically layout. All layout properties will be calculated and rendered. Next is you do painting. Basically you apply text, photos, background and other visual elements. Then you do composition, right? So when composition, basically we are talking about opacity or transformation. Now the last is basically combining all of them. The display picture is being generated, which is being going to be composed and then be painted on the screen. The last thing that gets applied is basically the JS or the JavaScript, which is going to bring about dynamic changes in our website. Now when we talk about layout, so basically layout basically deals with everything, right? It can be a flex, it can be a grid, it can be absolute, everything. Remember, although you describe flex as display flex, but then it is still a layout property because it is basically going to define a container, right? So that container is basically going to place your elements. The next thing that you do is painting, so where you have all the text and the other visual elements that comes into picture. Then is composition. So for example, if you have any transformation, that means if you're doing a for example, if you are trying to add any animation or anything that requires a little bit of more computation, that is going to be calculated in this stage. So the animation or composition will occur at the last, and then once that has been done, then the layout, painting and the composed element will be displayed on the screen. Now the last thing that is basically going to apply is nothing but called as the JavaScript or JS, which is basically going to be rendered on the screen. Now okay. So basically, after computing all of this, like after computing the layout, the painting and the visual elements, then is last thing what we do is basically composition. The composition is basically what is going to transform, or basically it is going to change in the opacity. Now the first basically, okay, now this is how CSS is working, right? Now why it is called as cascading, we'll see the cascading effect once we start writing some CSS. I have already told what the other two S stands for. This is basically for style sheets, because you kind of have a file that is going to indicate how the HTML is going to be styled, right? So hence it's called as a style sheet. Okay. Now see below is okay. So CSS is structured basically. Now the difference between CSS and other layout, for example, we have Swift UI, right? That is very much declarative in nature. However, CSS at times will that means, for example, whenever you are doing designing mobile app, if you say the properties for designing will be different, right? For example, this is a mobile screen, right? Suppose, so then if you say element at top, so it will, so like it will be h tag, v tag. You don't have all those attributes because Swift UI is not, is very much declarative, meaning it is the way you are going to declare the UI, that is how it is going to be rendered. However, CSS is a little bit more programmatic. It is also declarative, but it has, it kind of does little bit of thinking, and it kind of does inheritance for a lot of properties. That is, it inherits from many properties will be inherited from parent. Um, like suppose, so basically, it's not only declarative, but it has its brain of its own as well, and does inheritance as well to some extent. Okay. So it's not entirely declarative. It is a little bit programmatic and declarative. Okay. So now first this is basically we are going to learn about the first topic that we need to cover is basically CSS syntax. Then we'll do some, like we have already covered, but we'll try to revise little bit. We'll basically try to. Okay, so let's we'll do a deep revision, like a fast revision, but nothing will be lost. So first is basically CSS and selectors, how they work. There is something called as specificity that we need to pay more attention, or that is how CSS decides what property will override each other. Then you have colors. Then you have colors basically, and then you will have units. Then units and measurements, basically um, different types of units like pixels, rem, uh, and so on. Then we'll have fonts and typography, like how can we change the type of a default HTML by applying some sort of style sheet, or giving it some sort of style. Okay, so basically, how, so there are three ways you can apply CSS. First is basically you can so like how can we link CSS? So first is basically you don't link CSS. Instead, what you do is we can use a like CSS in HTML. This is basically CSS in HTML, and this is basically what you call as inline CSS. The next thing that we do is basically we have something called as um, the next thing that we have is basically styling in a sheet, right? So instead of linking, you declare CSS, uh, declare CSS um, in another page or uh, style sheet, and then from there you are going to link your CSS, or going to refer CSS back. Okay, so let's see how and like what are the advantages of each of them, and when should we use one. Let's go here, but then let's just I don't know. Do we have a style sheet? Yeah, so basically we just have a script thing, right? So what we can do is we can delete this, and then I'm just going to add my so to this I'm going to add my index.html file. So you have your index.html, then you have styles.css, basically the style sheets that is going to come. So there are other ways as well, right? Like there's something called as um, there are different types of like different variations of css. Although like css is a native thing, you can have basically something called as something called as a fast css. That also there is some okay, there is a I don't know, it's like a hidden layer on top, pcs or something. Some there are no uh, the css 1 2, and then so the currently the version that we use css 3. uh, so basically there you can css can be optimized for way these web pages as well. Okay. The golden one is css is like this the native css. So they have something called as tailwind as well. Now it is basically on top of css, and then you have something called as a ui. There are different ui libraries as available as well. Those are going to everything is going to be built on top of native css, right? So if you know native css, then you can do and or you can understand any type of css. Mm. So now let's okay, so let's try linking so we have our styles.css file available here, right? So let's go and let's add a link file saying, because we are going to link, right? So now let's see, this is my styles.css. Let's just add an h1 and then say this is header. And then what I can do is in my styles.css, you can go here and just change the color or just add some, like just to show just to test if the css is linked properly. You do background color and then you make it green. So it's not good practice to use style sheet in the file. However, what one can do is instead of using it in the same file, you can, like, instead of doing inline css, we should do something called as you should make use of different files so that you can structure them very correctly, right? Structuring becomes easier, and then debugging will. So this is basically my header that has been come up here. So there are key parameters as well when we define front end. For example, first content. So if you go here, oh no, not this. So if you go here, inspect, and then you see performance, right? The largest, so there are different parameters that which say whether your CSS, HTML, or your front end is good or not. So then the first something you have is called as the large content reference parent, or LCP, right? Okay, so what does this mean? La largest con- These are basically performance metrics that are going to relate to our CSS. So the LCP is basically a metric that indicates how the main content of a website becomes available. So basically, okay, now let's see. Okay, yeah, let's study how fast our front end is. So there are certain parameters as well, or metrics um, uh, that are responsible for checking whether the like how fast or slow was the rendering done. Rendering or basically front end generated, because this is very important, right? I mean, the user is going to see the front-end part, right? So there is first parameter that we saw is basically largest contentful page or LCP, right? So basically, it's a core web vital metric that measures how long it takes for the main content of the page, specifically that takes time for the largest image or text block within the viewport to become visible. So good LCP value should be less than 2.5. Okay. Now ours is in green, right? It's like 0.006. Even you can check it over here. So LCP is most important for perceived load speed because it points in the page load timeline when the page main content was like loaded. A fast LCP reassures that the page is full, right? Now historically it has been a challenge. Older metrics like load or DOM control loaded don't work well because they don't necessarily correspond to what the users see on the screen, because DOM tree is generated at the back, right? So if you have something that is blocking the DOM from getting parsed, so then you won't be able to get it properly, right? So now so there is other newer performance is basically first contentful. So if you see the word, it's largest contentful. That means the biggest or the largest viewport element. How much time is that taking to load? We are not checking. Okay, this is not basically checking the entire. I mean, like we are basically checking the. So first parameter is basically largest. Um Contentful paint, right? So basically this is giving indication of the like the largest viewport that came into existence, like how much time does it, so this is basically two different words, right? Paint is basically so when it is displayed on the screen it's called as paint. Now contentful is how much contentful is basically how much time did the largest viewport take to be painted on the screen, is something called as the LCP. Generally, this has to be in, so a good is said to be 2.6 millisecond, right? A good viewer or a user experience is said to be when my LCP is within 2.6 milliseconds. Then you have something called as after this you have something called as first contentful paint, right? So if you again split this one, you have three different parts to it, right? Paint basically means rendering, like when everything is ready to be posted. So basically it indicates how much time did the first contentful basically is indicate how much time is the first element or the first content being taking to be put on the screen. So a standard FCP value or yes, LCP value is basically 1.8 seconds. That means because it is user experience, right? So if the user sees that there is something coming on the screen, then um, then the user will be more interested in browsing the website, right? For example, if you go to amazon.ca, okay, and yeah, if you see and inspect here, And now if you go to performance, now see the largest container came out in just 0.41 now millisecond. And then uh did I have something else? You know, the okay. So the LCB or the last thing that came on to the screen was the speed tag that just took 0.41. So we are not talking about the first thing. So see the LCP has happened in just what was the last thing which came up was also is render is shown on the screen, right? If you go to so the moment if I refresh it, yeah, see the LCP or the last thing that came was this whole screen, like the whole background thing, that was the last thing that came out. Now there is some shift or cumulative layout shift that is 0.14. This is still not red, right? So if it is red, that means that it is a very bad this is still like yellow. I mean, red is something that is, it's still moderate, right? It's not bad. Now how to check FCP? I guess let's see how to check the first okay, so there are some tools like Chrome, paid insights or lighthouse. So let's see how to use using Chrome dev tools. So using generally during FCP, we generally show the open the panel, click reload. Okay, so the move. Okay, what are we doing? Is saying so basically during the FCP, the logo of the website is generally what we display. The reason to do that is we want the user to know that he's already on the correct website and you shouldn't move out. In the timing sections or web build, and okay, so let's reload this. If I reload the web page, and then do I have a timing section? There's elements, console, sources. So if you go to performance in the metrics, okay, let's. Is there any other metrics that I can record and reload? This is going to profile. Just give me 1 minute. This is going to provide the details of everything, right? Like how was the FCP, LCP. Okay, so now we are in insights. This is CSS. First, let's ignore that. Let's see this is how different things are occurring. Where is my? I need to. Let's. Uh, there should be something called as timing. If you go to performance, click on record and reload. This is going to. It says open the click reload to record the page and find the FCP in the timings. So navigate to performance panel, record, click the record button, save tools to analyze and prepare the report. So this is how the report is getting prepared, but then I'm not getting. I have insights, FCTP. Okay, this is different types of elements and how much time they took to render. Okay, let's let's see. We have if I have. There are other third-party tools as well. For example, you can use Lighthouse or there is something called as Lighthouse, right? Okay, let's go to Lighthouse. This will, I guess, it will log in or something. Lighthouse for performance testing. So let's go here. Let's try it for free. Ah, then it's need, yeah, this is something to log in. Lighthouse and an open session automated. Oh, is it this an extension or something? I'm trying to Chrome Dev Tools. I download Google Chrome for desktop. Open Chrome Dev Tools. Click the Lighthouse tab. This is inbuilt in okay, overview JavaScript. Mhm. So you get an idea, right? Because these are other tools as well that can. Okay, let's click on record. And then let's say stop. Now let's go to inside. So this is basically saying how much the oh, this is my page, right? I don't want to. I want to go. Let's refresh the tab. Let's go to performance, and then this is basically recording, right? So let's give it some time to generate. Uh, oh yeah, this is LCP has come, but yeah, I guess we have to wait for it to complete. But then yeah, that's okay. So and then when you have the other parameter you have is basically a CLS, right? Okay, so that is I guess average for. So what is CLS? CLS is basically stands for collect available. No. What is yeah cumulative layout shift. Now CLS unexpected layout shift can disrupt the user experience, causing them to lose their place while reading the text moves. So CLS basically indicates the how much percentage or largest burst of layer shift or unexpected shifts that occur during the entire life cycle of a page. For example, when we add some styling or some other feature, some contents or some layout pattern may shift, right? So that is basically measured by CLS. So that is cumulative layout. Cumulative is basically a cumulative score means like an average score or something. Cumulative is statistical. Yeah, basically, uh, cumulative is it average or something? Yeah, it's somewhat like cumulative mean basically known as it's a moving average. Basically indicates how yeah it gives like an average of the number of layout or number of things that shifted during the entire rendering cycle. These are all provided by so like either you can use the dev tools or there are some other third party libraries like Lighthouse or some other things that will um, that will indicate the average or the mean, like cumulative versions. Now, cumulative is basically a moving average. So, for example, you keep on adding the previous values to the average. So that is how a moving average is calculated. CLS will indicate like how many, it will give an average or a moving average of how many elements shifted during the rendering process. Now, what should be the CLS value in. So basically, it should be 0.1 or less. Okay, now if I go back here, if I close this thing, if I go to inspect and then I go to performance tab, it's 0.00. See, you just re-render it. It's like it should be 0.1, but it's not very bad. Like it's not too high. It's almost in the good range. So the value shouldn't be like this is a top-notch website, right? This is average value should be 0.1 millisecond. Remember, everything is happening in milli, right? That is like it's very fast for us to capture, although it does take some time. This is like it should be 0.1 seconds. Okay, so now these all are properties that are going to. These are like some important performance metrics that are going to indicate how fast or how slow our website performed when we try to load it. Oh no, wait, let's get back here. And then okay, let's see here. Yeah. Let's Yeah, I guess this is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye bye.